Carolina, how you doing? Okay. So,
So is this like the because we haven't checked it.
no, what you should do is drop the grouping symbols, cancel out the x's, and have 1 over x plus 1 squared. You could do what you did. What you did is not incorrect. It just makes it very complicated to analyze. You know, where is this positive, negative, and 0? It's very difficult to tell. But if you drop the grouping symbols, cancel out the x's, you end up with 1 over x plus 1 squared. Now you can analyze that. That's pretty simple to analyze. And what happens is this is always positive, as long as x is not negative 1.
Because it's squared, right?
Yeah, so it's never falling. Here's rising, oh, and here's rising. You know what? Your graph is pretty good.
So
It's rising all the
it
time.
does have the points of inflection too, right?
Well, are there any points of inflection? You have to take a look at the second derivative and determine whether you have.
Yeah,
Yeah, because that's yuck. Yeah, take this derivative of that.
Things nasty.
I got it wrong anyway.
Looking at that!
Yeah, I got it with drop down.
Wait, to the U.
No, no, no.
You sure?
No, I wouldn't be here. Why would I waste my time?
Yeah.
I would just yeah.
Is that second one?
What?
Denominator.
I got the derivative. I just don't know which channel to do it.
Looks at me.
Okay.
Says 0 minus 2 equals 2.
Yeah, you shouldn't have used the quotient rule, no, but that's all right. This will give you the right answer, but problem is, you should have left the 2 out front. And then you get an x plus 1, at least you can cancel
Yeah,
out
right.
one of the x plus 1s. So you got a negative 2 over x plus 1 cubed. Well, actually, you can see it.
Can I see your second?
Yeah, that's because
I don't know, something's wrong in there. So that should,
Because
if
I
we had a
had-
1 here, then you can cancel out. You get negative 2 over x plus
So
1
that's you
cubed.
used the 2.
All right, well,
I think we're stubborn.
all right, come on, you guys ready or what, Jeff?
I didn't get cubed. I just got it.
Rising, just pretty good, except, the only thing
You
is,
have to minus that.
0, 0 goes to the origin, and it has a horizontal asymptote.
It does go through one?
Yes, it does. It's 0,
You're right, you're right.
y is 0, and when x is 0. Where's your horizontal asymptote?
Oh, I know what I did wrong. Oh, wait,
Horizontal
asymptote?
tangent.
Oh, I didn't do that.
It has a horizontal asymptote, but it has a vertical asymptote. Oh, you did the vertical asymptote.
Yeah.
But it also has a horizontal one at 1. So if you draw this line at 1, this will go
I
up.
didn't do it, that's why I didn't read that. I just did the same as last time.
All right. Okay, you guys ready or what?
Yeah, we're ready.
Yeah.
We're
All
not
right.
ready.
Oh my god.
Let's
We gotta
do
do
it.
another one after this.
No, that's it. Everybody's dead. You're not dead though, are you?
No, not yet. I gotta do one more because
Okay, I'll give you
if
one
I don't
more.
get the right answer.
I'll tell you what I'm gonna do. I'm gonna go over this, and then I'll give one more to anybody who wants to do one more. So you can leave if you wanna leave, you can stay if you wanna stay. It's your call. But I'm gonna do this one here, and let's do it. All right, first of all, symmetry. No symmetry here. This is not an even function, and it's not an odd function either. It's not even, it's got to have x squares instead of x's. It could be odd, but this one messes it up, okay? So it's not odd either.
Which goes x squared plus 1.
If it's x squared plus 1 here, it would be,
Symmetrical.
yeah, it would be an odd function. It would work. But because it's just an x, it doesn't work.
Odd is over the origin, right?
Yes. All right, let's go for vertical asymptotes. Yes, we got a vertical asymptote. That x is negative 1. That's a vertical asymptote. So here's what we know. We know the graph cannot cross that line at x equals negative 1. Okay? Horizontal asymptote. You get a horizontal asymptote by taking the limit as x goes to infinity of x over x plus 1, and that's equal to 1. If the degrees are the same, this limit is the ratio of their leading coefficients. This is a 1, that's a 1. You can get that by dividing the numerator and denominator by x. You'll get 1. As x goes to negative infinity, it's also 1. Y equals 1 is a horizontal asymptote.
So like, the coefficient's 1, so 1 divided by 1 is 1.
Yes, correct. Now, you got to be a little bit careful with the horizontal asymptotes. It does tell me the behavior of the function as x decreases without bound and as x increases without bound. But it's conceivable that the graph would cross the horizontal asymptote at some point. It won't here, but it's possible that it does. Now, where is it rising? Well, we got to take first derivative. So let's do the first derivative. Quotient rule. Denominator. Derivative of the numerator minus numerator, derivative of the denominator over denominator squared. Drop the grouping symbols, x's will cancel, we'll get 1 over x plus 1 squared. Okay? Now, we want to know where it's rising. It's rising where the first derivative is positive. Well, 1 is always positive, and x plus 1 squared is always positive as long as x is not negative 1. So this thing is going to be rising all the time as long as x is not negative 1. And it can't be negative 1 anywhere, so it's undefined there. Okay? So this is a graph that's rising all the time. Now what about falling? Where is this negative? That's positive and that's never. It's never falling. Okay? No x's make that negative. Where we got horizontal tangents? We got horizontal tangents where the numerator is equal to 0. 1 is not 0. We have horizontal tangents nowhere, never, no, none. No horizontal tangents here.
Because you can't equal to 0?
Because the numerator is not equal to 0. The only time a fraction can be equal to 0 is when its numerator is equal to 0, and that numerator is 1, never 0. Where is it concave up? Well, it's concave up where the second derivative is positive. Let's do a second derivative. Now, how do you take the derivative of this expression? What you should do is treat this as x plus 1 to the negative second, and not use a quotient rule. Because the numerator is a constant, there's no need to use the quotient rule. I would recommend you look at this and say, that's x plus 1 to the negative second.
On the top or bottom, you don't have to use
That is correct. That's the rule. So what's the derivative? Negative 2, x plus 1 to the negative third. Okay? Subtract 1 from the exponent. You get negative 2 over x plus 1 cubed.
Man, that was way easier.
Yeah, it's true. All right. So where is it concave up? Where the second derivative is positive. Well, let's see. This is a negative number always. What value of x would make this also negative so we get something that's positive? Well, when x is less than negative 1, x is less than negative 1, this is going to be a negative number. Cubed is negative. Negative divided by negative is positive. So x is less than negative 1. When x is less than negative 1, we have a graph that's concave up. Okay. What's that? Where is this? Concave down. It's concave down where the second derivative is negative. Where is the second derivative negative? Well, where the denominator is positive. Where is the denominator positive? When x is greater than negative 1. When x is greater than negative 1, this will be positive cubed is positive, negative divided by positive is negative. Where do we have a point of inflection? Well, we have a point of inflection where the second derivative is equal to 0.
The numerator, right?
Yeah, and when is this fraction equal to 0? Where its numerator is equal to 0, and that's never. The numerator is negative 2, and that's never 0.
Well, I thought maybe it was that point that it meant,
Say that again.
at negative 1, 1,
On
on the graph.
the graph,
Negative 1,
negative 1 is a vertical asymptote where the function's undefined, and where the graph will not cross this line.
yeah.
Okay? So where do we have a point of inflection? It's not at negative 1. That would not be a point of inflection. We have no point of inflection. There are none. Because there's no x value that causes this numerator, negative 2, to be 0. To be a point of inflection, you have to have that second derivative equal to 0, and this is never equal to 0. Okay? The graph then, let's do the graph. Well, what do? We have a graph that's rising all the time. It's concave up when x is less than -1, and there's only one way to do this, given our asymptotes, this way. Rising and concave up. And it's falling, okay, never, and it's rising then after -1, but concave down there. Rising and concave down. What do you have for rising and concave down? This is what you have. And the other point would be the 0, 0 point. You can see when x is 0, y is 0. That's one to check with, okay? You should check that one. This is the graph. Rising all the time, up, down, no horizontal tangents. That is the graph.
Next, please, 4.6.
What's that?
4.6.
That's what this is, 4.6? Summary of curve sketching? I don't know what it is. All right, I'm going to give one more to anybody who wants to stay. Okay?
I have a question.
Yeah, go ahead.
So the point of reflection,
Inflection, yeah?
inflection, the numerator has to equal to 0?
Correct.
Okay.
The numerator must be equal to 0, making this fraction equal to 0. And since this numerator is never 0, there is none. I'm going to give you one like this again, okay? It's going to be like this.
On test?
Yeah, the one on the test is very similar. The one on the test may be this one. I may have to change it now. All right? But it's going to be very similar. All right, here we go. Let's do another one. We'll do one more.
I don't want to have to stay.
See you, Jeff. Let's do x. I'll make it a little bit more complicated. How about x squared over x minus 1? Try that one. It's a
We're
little
supposed
bit.
to find out if it's out.
Do the whole 10 questions.
Shebang.
The whole shebang. This one's going to be a little bit more complicated.
Okay, so x squared.
Well, I'll say it's a little bit more complicated. It's a lot more complicated.
Okay, so. So is this neither?
Hmm?
No symmetry at all? Neither?
No symmetry.
Awesome.
No, neither even nor odd.
Awesome.
Yeah, this is much more complicated.
Was it the denominator or numerator that if it was x to the thing that would be infinity?
This last one that we did.
On the bottom, would it have to be at the bottom, the x squared, or at the top? Remember we went over that last time?
The limit infinity,
I'm not sure what you mean.
the limit is
The x squared, you're not going to divide it by x squared on each side.
Yeah, you are going to divide by x squared, but when you do, what happens is that limit will go to infinity.
And if it was on the bottom, on the other hand,
It would go to
it
0.
would go to 0.
That's
Okay,
correct.
that's what I was asking.
So the limit goes to infinity.
Yeah, there is no horizontal asymptote.
Right.
The first derivative is a little,
First derivative is complicated.
it looks more complex than,
It's much more complicated because you get that numerator that's quadratic. Now, fortunately, the denominator is a square, so you know when that's always positive. So you're going to have to look at the numerator, see where it's positive or negative to determine when it's rising and falling. I would recommend that you, well, just keep on going, see what you can do. The second derivative is a pain in the neck, is what it is, though. First derivative is bad, but the second derivative is worse.
I got 2x cubed minus 2x minus x squared.
What'd you get?
No.
For a second derivative?
Yeah, over x minus 1 squared.
So
Oh, I thought that
not,
was your first one.
Wait, whoa, I have to pull it out, right? I have to max out or something?
yeah,
I
yeah,
gotta keep going, I'm just.
yeah, that may be right. Yeah, this is nasty, second derivative. I gotta tell you, I would recommend that you don't even bother with the second derivative. Just go to the first derivative, because the second derivative is nastiness.
May I take everything up until this point? I have to go my reds here.
Okay, what did you want to do with these, Nick?
I gotta take a photo of all of them.
He's gonna take a photo of them. Can you get them tomorrow morning?
Tomorrow morning, no, I'll just get them on Monday.
You're not coming in tomorrow?
No.
Don't you have class tomorrow?
No.
Pre-calculus?
I have babysit.
Oh, whatever, you don't have to, yeah, we don't have to go into detail.
You just asked me.
Wow. I thought you had class, I thought you were here.
But things came up.
All right,
Life
okay.
happened.
All right, see ya.
I'm just gonna try the homeworks.
What?
I tried to do that, a lot of people more confused.
Oh,
Because the homeworks I checked, they have the little tutorials.
yeah.
And I kind of walk through those step by step.
Oh.
The video.
So you want me to do this one right now? I'm gonna go as far as the first derivative on this. It gives us the information we need. The second derivative is confirmation, but the first derivative tells me everything we need. All right, I'm gonna just go through that. You're gonna leave? It's up to you. I mean,
I just don't want to get all into it because I'm
Yeah.
getting more confused.
oh, really? More confused seems to imply that you already are confused. Are you confused now? Someone?
I'm
Question.
confused on one.
Go ahead.
If you plug in 2, for example,
Yeah,
it would equal to 0.
correct.
So would all of them be positive because this bottom derivative is other than 1? Other than 1, it would be positive, right?
Other than one, it is positive always,
But
yes.
here, it wouldn't matter because it's times 2. So anything be, let's say, 1 and 1, you can't do that anyways.
Yeah, you
Let's
can't.
say it's 0 and 0, that would equal 0. over
Correct.
1. And then negative 1, that'd be positive 1. And then minus 2, that would equal... So at negative 1, would it become negative?
At negative one, the second derivative, no.
Why
At
not?
negative one, the first derivative is positive. Oh, because a negative one squared is 1, minus 2 times negative 1 is negative 2, but you're subtracting negative 2, so you're adding 2.
I gotta plug it in.
Yeah. Let me do it, all right? Because I can see this is probably counterproductive with this one here. Me and my stupid idea of taking the x squared
okay,
thing
so
there.
it's always rising.
No, it's not always rising. It's going to be falling between 0 and 2. Here, let me do it out. Let me do it out. Let's do this one out.
I mean, I'm okay.
This one's nasty. All right, first of all, Vertical asymptote, yeah, we have a vertical asymptote at x equals 1. That's pretty straightforward. Okay, we got a vertical asymptote. We do not have a horizontal asymptote because when you take the limit as x goes to infinity, this will go to infinity, okay? And when as x goes to negative infinity, okay, what happens here is this limit will not exist either. What will happen is this will go to negative infinity, okay? So neither limit exists. One goes to positive infinity and the other goes to negative infinity, okay? That's what's going to happen there. Let's take that first derivative. Denominator, derivative of the numerator, minus numerator, derivative of the denominator, all over denominator squared. We'll get 2x squared minus 2x minus x squared, x minus 1 squared. 2x squared minus x squared is x squared minus 2x, x minus 1 squared. And that's x times x minus 2 over x minus 1 squared. This is everything we need, though, okay? Watch what happens here. All right, first derivative, positive. Well, the denominator is always positive, as long as x is not 1. But the denominator is positive otherwise. What about this numerator? This numerator, if you just graph the numerator, it's a parabola, concave up at 0, and it has a 0 at 0 and 2. The numerator looks like this. Okay? So, what do we know? When is the first derivative positive? It's positive when x is less than 0, because this part will be positive, and this is positive, or x is greater than 2. This is positive, and this is positive as well. X is less than 0 or greater than 2. The first derivative is positive, and the graph is going to be rising, okay? As long as x is less than 0, greater than 2. Where's the first derivative negative? It's negative between 0 and 2. Because this is negative, but this is positive, okay? So it's going to be falling from 0 to 2. Now, it can't cross this line here, but it's going to be falling and then falling again. Now, where's the first derivative equal to 0? It's equal to 0 when x is 0 or x is 2. And these are important, so let's substitute these back into the original to find my horizontal tangents. When x is 0, y is 0. So at the origin, we have a horizontal tangent line. Okay? Or x equals 2. When x is 2, we get y is 4 over 1, we get y is 4. So 2, 4 is another horizontal tangent. So we got a horizontal tangent and a horizontal tangent. This is 2, 4. Okay, this is everything we need. Here we go. This graph, when x is less than 0, is rising when x is less than 0. It's going to be rising when x is less than 0. It has a horizontal tangent. It falls greater than 0 this way. Now it can't cross this line, so it's going to fall just like this. Okay? Like this. When x is also greater than 1, we need a horizontal tangent here, it's going to be falling and then falling to a horizontal tangent. At 2, hits the horizontal tangent, and then it's going to be rising again. Falling, horizontal tangent, rising. Rising, horizontal tangent, falling. This is the graph.
Without doing the second derivative.
Yeah. The second derivative would tell us, it's a giant zoo, it's concave down when x is less than 1, it's concave up when x is greater than 1. And there's no horizontal, there's no points of inflection. I'm not going to give you one like that, though. But I will give you one like the previous one. And I will give you a cubic polynomial. Those are the two you're going to graph.
One of each.
One of each. Okay? You also have a mean value theorem problem, and you're also going to have 2 max min problems, which I will do on Monday. Okay? The differentials are not there. I'm going to see if they're on WebAssign now.
I know it goes to 4.8.
Okay, well, I'm going to have to check it out. I will do enough on the differentials so you can do the homework, but we're not going to do anything beyond that.
Or we could just take out homework.
Could do that too. Could do that. But I won't. I'm going to leave the homework in there, but we'll do enough to do the homework. I think I probably put one in to do an approximation just to show you how the differentials used to be used. I think that's what it is. Differentials are used in Calc 3 though for propagated error, but up until then, they're not useful. All right.
Thank you.
For
See you
anyone who
Monday.
wants to see the videos from last class,
Who does?
anyone, I don't know.
Oh, anyone. Yeah, go ahead.
SDCC calculus, just type it into YouTube.
Sweet,
That's nice.
yeah.
That's
Your
pretty
hands
cool.
moved up too?
You should put
Yeah.
Calc 1.
Nice.
Well, for now, I just burned, why do you think I was walking back and forth? I
Yeah.
just uploaded them. I don't know
Cool.
how they are. Whatever that thing got, that's what I put on there. I didn't do it. So
Yeah, right.
Okay, that's cool.
it has 4 parts. The last part, I think, is small.
Wow. Thanks, Nick. That's pretty good.
Yeah, so
STCC calculus.
That's true. It equals a ZNE. I know. I keep writing it. Well, I like it.
gotta turn the volume down.
It goes to infinity.
Should edit me out of there. I'm editing me a lot because I digress so often though, you know what I mean?
And we got,
You hear Burns get fired?
What? What did I say? I didn't say anything bad last time, did I?
I'm just saying, like the videos, they do the whole thing. Not just joking.
Wow. So I'm going to be competing with Kim Kardashian, maybe? No, maybe not, huh? All right.
I think where do we find the actual just papers on there? I'll do it right now.
Damien.
Did you take pictures of all of them yet?
No, I don't take pictures of any of them. All right, so you got to do that.
The pictures are on WebAssign.